Welcome to Science Lecture Theatre. I am your lecturer, Professor Efa O. Efa. In this lecture, we are going to learn how to find the foot of the perpendicular on a line from a given point. Understanding the problem. Given the equation of a straight line, ax plus by plus c equal to 0, we want to find the coordinate of the foot f of the perpendicular on this line from the given point px1, y1. Let us illustrate the problem graphically. Here is the given line ax plus by plus c equal to 0. And this is the given point px1, y1. The perpendicular drawn from this point P meet the line at the point F. This point F is the foot of the perpendicular on the line. In order to find the coordinate of the foot of the perpendicular on the given straight line, we need to obtain the equation of the perpendicular line and then solve it simultaneously with the given line. To do that, we first of all determine the slope of the given line ax plus by plus equal to 0. So, rewriting this equation in slope-intercept form, we have y equal to minus a over bx minus c over b. Hence, the slope of ax plus by plus equal to 0 is m1 equal to minus a over b. And the slope of the perpendicular line pf is m2 equals to minus 1 all over m1. This is equal to b over a. We can now find the equation of the perpendicular line PF. PF is the line passing through the point px1, y1 and having slope b over a. So the equation of PF is y minus y1 equal to b over a into x minus x1. Rearranging this equation, we obtain bx minus ay equals to bx1 minus ay1. We are now ready to find the coordinate x2, y2 of the point F. We know that fx2, y2 is the point of intersection of the two lines. That of the given line, which is ax plus by equals to minus c, and that of the perpendicular line, which is bx minus ay equal to bx1 minus ay1. Solving these two equations simultaneously using Cramer's rule, we obtain x2 equal to x, which is the determinant of the matrix in which the first column are the right-hand side of the equations and the second column are the coefficient of y. The denominator is the determinant of the matrix of coefficient. Now, evaluating the numerator and the denominator, we have ac minus b squared x1 plus aby1 all over minus into a squared plus b squared. And this is equal to b squared x1 minus aby1 minus ac all over a squared plus b squared. Also, y2 is equal to y, which is equal to the determinant of the matrix in which the first column are the coefficient of x and the second column are the right hand side of the equations. Denominator is the same thing as that of x. Evaluating the determinant, we obtain abx1 minus a squared y1 plus bc all over minus into a squared plus b squared. And this is equal to a squared y1 minus abx1 minus bc all over a squared plus b squared. Let us take an example. Find the foot of perpendicular f on the line 3x minus y plus 11 equal to 0 from the point 1 minus 5. Solution. Here, a is the coefficient of x, which is 3. B is the coefficient of y, which is minus 1. And c is the constant term, which is 11. The point x1 is 1 and y1 is minus 5. We recall the equation of the given line is given by ax plus by equals to minus c. This implies 3x minus y is equal to minus 11. And the equation of the perpendicular line is bx minus ay equal to bx1 minus ay1, which implies minus x minus 3y is equal to 14. Solving these equations simultaneously using any known method, we obtain x is equal to minus 47 over 10 and y equals to minus 31 over 10. So therefore, the coordinate of f is the pair minus 47 over 10 and minus 31 all over 10. We have come to the end of our lecture. Thank you for watching and keep on watching.